Hey, it's Tom from Tormach. I'd like to introduce you to a new series of videos that I'm going to be creating here for our YouTube channel. As product manager here, I'm often asked about the performance of the machines, the types of materials we can cut, the different kinds of speeds and feeds you can expect. And I wanted to take you behind the scenes of the types of testing that I do on my machine. I have a lab in North Carolina where I live. But I wanted to just take you behind the scenes and be really transparent about what we do here and how we work through it. So they're rough videos, they're not highly produced, but I just wanted to give you an introduction here. Because what I'm trying to do is get you a start point for what you can do. So I start with just some basic industry standards of what you might expect for a particular material. And then based on how that machine is responding and how the tooling is responding, I go ahead and make some adjustments to it, with the target of keeping my spindle load at a level that could be run continuously. You can run much harder than this. In fact, I did testing on this machine, or on my machine in particular, and I was at 300% spindle load. And so you can see a picture of those chips here. But again, you're gonna have to adjust this based on what your work holding is, the type of tooling you're using, things of that nature. The tools that I'm using are all tools that you can get with the machine when you buy it from Tormach. They're not anything fancy or special. Maybe I'll do some testing with something special if there's enough of a request for it, but for right now, I'm just gonna focus on the basics. And this week's video is gonna start with 304 stainless steel. We're at about 70% spindle load. All right, that's the end of the roughing cycle for facing. If we take a look, it's not bad. I think I would have, if I were doing this and that was the finished surface I was going for, I would probably, that was 100 thou depth cut. I probably would have done a 90 thou depth cut, left 10 thou for a cleanup pass, and then done that with fewer step overs as well. You know, I was trying to keep the spindle load, you know, about 100% on this one. Yeah, so this is part number 53084. It's a 4-flute YG face mill, 1.5" face mill. You can get a little bit of a better look there. It uses either SEKT or SEHT, if I remember right, for aluminum. And yeah, you can get this right from the Tormach website. All right, we're going to use this 5/16 cutter. It is one of the ones that comes in our high performance tooling kit for steels, for ferrous materials. It's a YG cutter. This particular tool path is coming to us from default settings and pre-tool from toolpath.com. So let's see what we get. pretty conservative tool path. Not bad. Spindle load. Let's take a look here in a second. I want to give it one complete pass around the outside before I make any changes here, but we're doing a 1/2 inch depth of cut. It's interesting why I'm getting a lot more noise that direction. Alright, so let's see. So, you know, not exactly pushing things. .200 surface feet. So what you would expect for 3 or 4 stainless. We're coming in right around 35 to 40% spindle load. Alright, I bumped up the feed rate. It's 200%. Just to kind of see what we're getting. Spindle load's not too bad. I'm still getting this weird harmonics when I'm cutting on that one side for some reason. I mean, there's a lot left on the table. We could be pushing this harder. Alright, so I bumped all the settings up. I'm now at 300 surface feet and 4 thou per tooth. It should be catching up here soon, so I just want to see where we're at. Alright, we ought to be hitting it here. There we go. So this is our actual cuts now. You notice we're not getting that chatter this time either. And if we look at our spindle load, we're hitting about 80%. We're leaving a little bit on the table. But that's what I'd want to see. So we'll work with the toolpath guys to maybe refine that library a little bit. There we have it. Alright. And we can see, especially on this left side here, right? You can see where I made that change. Going from 200 surface feet to 300 surface feet, you can see the floor finish changed quite a bit. This was that side that was, for whatever reason, was catching a lot of chatter when we were going that way. But yeah, not bad. You know, for a roughing tool pass, you see a reflection on my finger. Again, this is a roughing pass. You'd want to, or adaptive tool paths or roughing passes. You'd want to do finish passes on this, but not bad at all. I'll take that. Alright, so this is 304 stainless. We're going to do a light facing operation, pull off about 40 thou or 50 thou total. And then we'll go ahead and run some stress testing on a 5/16 YGN mill. There's a lot of coolant in the way, so I'm not sure how much video I'll be able to clearly get for you. Alright, I just blew the part off, cleaned it off a little bit, and you see, nice surface finish. Not bad, 304. Alright, our next tool, 5/16 end mill. Surface speed. And 4 thou per 2 chip loads, 4 fluid end mill. Alright, so now we're doing a 3/4 inch depth of cut. And I slowed down the feed just a hair, although I think I might bump it back up because I'm starting to hear that ringing a little bit. Yeah, I'm going to move to manual override.
it up just a hair. Alright, to give you an idea, at 3/4 depth of cut, we're starting to get a little over into the 110, 115%. You can see I got my feed rate override at 125%. We're running about 55 inches a minute. Trying to give you something to look at through all that coolant, but it's tough sometimes. And there's our part. All right, here's our part. Remember, this is 304 stainless. We're doing that with a 5/16 end mill, 4-flute end mill. Just an ER20 holder. We're doing an adaptive. If I really were worried about using the floor finish, I would have, remember adaptive is a roughing toolpath, so I could have cleaned that up. You can kind of see here on that 3/4 inch depth of cut. We were pushing a little bit more, but you can see we're getting a really nice surface finish on here. You can see my fingernail pretty well through that. I am happy. Remember, you can get all this tooling when you buy your machine. You just add it with the machine builder. Okay, so what we saw is the industry standard for 304 stainless is to run at 200 surface feet per minute. And a chip load, it was a little about, or it was right about 1.2 thou inch per tooth, right? And what we ended up running at as an optimized load, because that really got us at about 30%, 35% spindle load. But our optimized toolpath that we did got us to 300 surface feet per minute and 4 thou per tooth, so significantly faster material removal rates. So I hope this helps you when you're getting started. Again, you're gonna have to make some changes to this, but this should get you a really good starting point. Thanks again, and I'll see you in our next video.